Good morning, everybody. I hope you're having a good day so far. For anybody who may be out sick today or our person that we miss very much because they are injured at home, I just am praying for you and I hope that you feel better soon. Since this is a public video, I'm not going to use your names, but you know who you are and know that you're loved and you're prayed for and care very much about you and hope that you're going to be back with us very, very, very soon. All right, that being said, here we are. We're ready to talk today about more having to do with triangles. I told you the whole chapter was going to be about triangles. So what we have on the agenda today is to talk about what congruent triangles are and how we know that we have congruent triangles, and actually begin to be to the point where you're going to be able to do some proofs where you're responsible for doing them from beginning to end. Before everybody gives a collective groan there, I want you to realize that you can do it. This is not beyond you. Okay, for these, it's basically just a way of making a glorified list where you're going to be checking things off. So let's just get ready to dive in and be ready. Hopefully you've got your sheets ready to write things down. Make sure everybody is paying attention to all of this. Okay, so first of all, you know what this symbol means. It means congruent. It's congruent for all figures that might be exactly the same as each other, not just for segments and not just for angles, but that can apply to triangles as well. So that means that one triangle would be exactly the same as another triangle. It would have pieces that match up, okay? Circles are congruent specifically if they have congruent radii. Okay, so a radius of a triangle, as you know, a radius of a circle goes from its center to the edge of the circle. So as long as they have that same length of that center part, then those circles are congruent. Polygons specifically are congruent if their sides, their corresponding sides are congruent and their corresponding angles are also congruent. As I said, we're jumping in and really focusing on triangles right now, so the rest of the lesson is specific to triangles. Okay, so I want to define very specifically congruent triangles. You know in a proof that sometimes we have definitions. The definition of a pair of congruent triangles is that all of their corresponding sides would have to be congruent, and all of their corresponding angles would also have to be congruent. Okay, notice that these triangles, this one's one way, this one seems to be kind of upside down and turned a little bit. When we list congruent triangles, we list all of the angles or all of the vertices of one of the triangles in whatever order we want. And then for the other triangle, what we do is we make sure that the corresponding parts line up. So for example, because angle A is the same as angle D, we would put D first in the second triangle. And because B with the 2 marks is the same as E, we would have to put E next. And then because C has the 3 marks and it matches the F would have to be next. So the corresponding angles have to actually line up with each other. If I wanted to, I could have said triangle CAB, but then I would have to say is congruent to triangle FDE. CAB would be congruent to FDE because the corresponding angles have to line up. The important way that that says, that comes out, is that corresponding parts of congruent triangles are congruent. This is a fact that we know. It, for whatever reason, does not really fall under the theorem or postulate category. It's really just another twisted way of putting the definition of congruent triangles. However, the fact that corresponding parts of congruent triangles are congruent is something that has to go through so that whenever you have two triangles that are listed as congruent, you can find all of their corresponding parts. So looking at here, at this set of triangles, it's kind of hard to tell by looking as far as which pieces would go together. But what we're given is this, which tells us which parts go together. It tells us that R and M go together and T go together. We'll talk about that one specifically in a minute. And Q and B go together. So when we need to list all of the corresponding parts, let's break that down and work it through. Okay, we need to list all of the corresponding parts. Well, we're told right here that R goes with M. So angle R is congruent to angle M. We are also told here that angle Q is the same as angle B. Angle Q is congruent to angle B. You might be saying, well, wait a minute, we also know that angle T is congruent to angle T. Well, sort of. This angle T is congruent to this angle T. They are two different distinct angles, but they do happen to be equal to each other. So we have to use the three-letter method so that we know which angle T we're talking about. There's actually four angle T's shown here. There's this one, but there's also this one because it has T as a vertex, and this one that has T as a vertex, so we have to be specific. So I could say angle RTQ is congruent to angle MTB for that third angle. Now the angle simply is the rays that make it up and then how far apart it's spread out. So those go together. Now we haven't listed all of the corresponding parts, congruent parts yet. These are just the angles. The other thing that we need to list are the corresponding sides. Okay. Now when we start thinking about the corresponding sides, we can let our labels help us. This tells us that RT goes with MT. Here's MT. These are the corresponding sides. Sides are segments, so please be careful to label them correctly. Segment RT is congruent to segment MT. You could even do this technically without having a drawing, but marking on the drawing is going to be extremely valuable to you as you go through. Okay, so we need to be used to doing that. Okay, TQ goes this way. It goes together with TB. Try to anticipate it a little bit, please. So QT congruent to TB. And then finally, we've got the other sides that are left. We have QR. Now QR, these do go together. We have QR, 1, 2, 3. MB are in the same spot, so MB also goes together. It's also the only side that's left, so it has to be congruent. QR is congruent to MB. All right, so listing all of the corresponding parts. We have 3 pairs of angles and we have 3 pairs of sides. So that's an important thing that you're going to be able and need to be able to do. Back to here. Okay, I already talked about how you can't just say angle T congruent to angle T. The next thing that we need to look at is if we're given some information and we're given a number of degrees, finding another one. Remember I said yesterday that it's kind of like a puzzle. So let's work on solving this puzzle. Okay, so angle R is 31 degrees. And I want to label these in. Labeling your picture is huge in these problems, so please always label your picture. Angle QTR. Don't forget, in order to find out where that is, it's up here. You can trace it out. Q to T to R. T is the vertex, so this angle right here is the one that's 108 degrees. And we want to identify the one we're trying to find. We're trying to find angle B. So we're trying to find this angle right down here, angle B. So how many degrees is in here? Okay, well, we are given something. We are given the triangle RTQ. RTQ is congruent to MTB, just like we did before. And so that means that angle Q and angle B are the congruent ones. Angle Q is congruent to angle B, which means that their measurements, the number of degrees, are going to be equal. So this one is actually the same as this one. So if you can find this one, you already have this one. From yesterday, we said that the triangle sum theorem tells us that there are 180 degrees in the interior angles of a triangle. And very good that some of you yesterday were able to tell me how to solve and find that missing angle. Hopefully you remember. Okay, if somebody wants to pause and say it, that would be great right now. We would take 108 plus 31. That would tell you how much you have so far, then subtract from 180, giving you 41 degrees. So the measure of angle B equals 41 degrees because it's the same as the measure of angle Q, which equals 41 degrees. Okay, marking in your picture helps that, because once you identify them, and you can say, oh, I could find that because I have enough information in my picture. So super important to mark your picture. Okay. All right. Now, where we come to for this, notice that we have a proof. It's asking us to prove that 2 triangles are congruent. This is going to take a minute, but I want to bring us through. Every one of you is going to be capable of doing these types of proofs where you prove triangles are congruent. We are going to learn a few theorems that are shortcuts. But before we can learn the shortcuts, we need to start exploring and do one that is a long version of this. I wish I was able to be there today, and I wish I was able to have you guys give me your thoughts on what you would do next in a proof like this, but our goal is to prove that the triangles are congruent. All right, so what we're going to do is we're going to make a statement and reason column. work our way through. So you need to do that. You need to follow along as we go. So our first thing, probably all of you are itching to say, is to put in the given information. So let's do that one thing at a time. BD and AE bisect each other. We have to remember what bisect means. Take your time to write it down. Angle A, actually I'm going to use another color here. So I want to make it stand out. You can use colors or not, but I'm just trying to draw your attention. Angle A is congruent to angle E. And I want to go ahead and mark that right in my picture. Here's angle A, here's angle E. And then the last part of the given information, segment DE is congruent to segment AB. So DE is congruent to AB. And I am going to say that that's given. Okay, so the only way that we have to show that we have congruent triangles right now is because of the definition of congruent triangles. And that would be that all of the corresponding parts are equal or congruent to each other. So far we have this angle congruent to this angle, and we have this side congruent to this side. So we have to start exploring what else is in our given information. We also have to start exploring what we have in our picture and find other pieces, other things that are equal to each other that we know good reasons about. So I want to draw your attention to the idea that BD and AE bisect each other. And I want you to think in your mind what bisect means, okay? Bisect means cut in half. So if they bisect each other, that means that AE cuts DB into two equal pieces. And it means that DB cuts AE into two equal pieces. They cut each other in half, which gives us congruent pieces. That tells us that AC and CE are congruent. Wait a minute, how do I know that they're congruent, you might say? I hope you say that. Where did I get that from? I got that from this fact right here, that they bisect each other. And how did I know it? I knew it because I know what the word bisects means. By definition, bisect means it cuts it into two equal pieces. So by definition of bisect, that's my reason that I know that these two are equal to each other. It says that they bisect each other, so we can also say that CB is congruent to CD. And guess what? I'm already moving along in my proof pretty good because I have all three pairs of congruent sides marked congruent. So now I'm going to try to work on getting those angles taken care of. So let's do that. Let's look at a step 3. Okay, so in our picture, one thing that I hope is sticking out to you is that you have a pretty obvious pair of congruent angles inside these triangles. And that would be this one and this one. So I want you to be thinking for a minute how I would know that these two angles are congruent. Think about what they're called, what their relationship is. Got these two lines that when you crisscross them, you get these two that are congruent to each other. Hopefully the word has popped into some of your heads by now. They are vertical angles. And the vertical angles theorem says that these two are congruent. I can't say angle C is congruent to angle C because this is and this are two different angles. However, I can word it like this. I can say angle DCE is congruent to angle BCA. So angle DCE is congruent to angle BCA. I'll just neaten that up for you a little bit. There we go. Because they are vertical angles. So far, what do we have? We have all three pairs of sides. We have two pairs of angles. So we're looking for that last pair of angles, and we need to be able to find a legitimate reason for those two things being equal to each other. We have only one left. We have B and D. And I can tell you right now we have two of the three angles congruent already marked. Yesterday we had a theorem that said if two of the angles are already congruent, then the third angle has to also be congruent. We were able to abbreviate that with this. Two angles congruent means that all three of the angles in a triangle have to be congruent. How do we put that? We say that angle D is congruent to angle B. So that we are now to the point where we have all of the corresponding parts lined up with others. So we have that triangle ABC is congruent to triangle EDC because I have all of the angles and all of the sides, and we said at the beginning of the period that that is the definition of congruent triangles. And that's kind of a long way to go about making a proof because we had to find all of them. So like I said, what we're going to be doing is we're going to be finding some shortcuts to that where you don't have to show all of the corresponding parts, but it's going to be enough to show that you've got congruent triangles. So we were able to review a few things, like the definition of bisect from the other chapter and vertical angles, use something that we had yesterday, and then from the beginning of today in this proof. These are the fun proofs. I'll just call them the fun proofs because they're nice. You're kind of doing a checklist to figure out what you have and what you still need to have. All right, so just one more thing for today. And that one more thing is that all of these congruences, triangles, circles, and polygons, are all equivalence relations, meaning that they are reflexive, symmetric, and transitive. So you can use these words. Remember, reflexive said something is congruent to itself. Symmetric, you can switch the sides of the congruent sign. And transitive, if two things are congruent to the same thing, they're congruent to each other. So we can apply that to our triangles, or you can apply that to any geometric figures. So if these are random geometric figures, this is not point A congruent to point A, it's just random geometric figure A is congruent to itself. A congruent to B means that you could also say B congruent to A, symmetric property. A congruent to B and B congruent to C implies that A is congruent to C, just because they are congruent to the same thing. All right, so that wraps up our new material for today. Your job is to work diligently the rest of the period on the homework assignment that is due on Monday. And I hope everybody has an amazing weekend, get some rest, gets into the thankfulness spirit, be ready to be thankful for all the things and blessings that God has given to you, and have an amazing weekend.